Hello all, welcome back to my channel. Please like, subscribe and press the bell icon so that you don't miss out on any of the upcoming sessions. In my last session, I have explained the theory and functionality of KMP algorithm. As mentioned in that video, in today's session, I'll be explaining the algorithm for computing LPS table and therefore performing the pattern matching using KMP. Let's stick to our original example where we have seen that your original string is this one and the pattern is this one. We have also seen how to create LPS table theoretically in the last video, and this is how it will look like. This is the LPS table that we have seen in the last video. If anyone wants to refer last video on KMP, link is mentioned in the comments. Please go through that video first before understanding the actual algorithm. We have seen that KMP algorithm consists of two parts. The first part is the pre-processing step and the second one is the pattern matching algorithm, that is the actual KMP algorithm. So let's see how the pre-processing algorithm will look like. Pre-process LPS table, and we'll be passing two parameters to it. One would be the pattern in itself and the other would be the size of this pattern. So the size of the pattern is m and the size of the string is n, and this function will be responsible to return the LPS table or the array. Now we are going to initialize few variables. We will be having a variable length whose value would be 0. Then we would be initializing, or we will be having an LPS array. We always initialize LPS of 0 as 0. The 0 index will always be 0. And then we will have an index pointer I and we'll start it with 1. Since we have already mentioned that the value at 0th index would be 0, so we'll be starting I from 1. Now we will have a loop while where we are saying that this pointer is less than the length of the pattern. If that is the condition or if that is true, then we are going to check the characters in this pattern, the character at index length and the character at index I. If these two characters are matching, then what we are going to say is, we are going to do is length plus plus, and we are going to assign the LPS of I as equals to length. Why we have done a length L plus plus here is that because what is this LPS table? This is nothing but the length of the maximum prefix that is also a suffix, and both should be proper prefix and proper suffix. So if the two characters are matching, it means that the length of the maximum prefix here is plus 1. So we do a length plus plus, the characters have matched, and we will also increment the I pointer. Now let's say if this was not the case, then what we are going to do is, we are first going to check else. If length equals to 0, that is also a possibility that length is 0. In that case, what we are going to do is, we are going to simply say that LPS of I equals to length and increment the I counter. Okay. But what if this length is not 0? In that case, what we are going to do is, we are going to reassign the length variable, and what would be the value is LPS of length minus 1. It means that we have to start a little back again. Okay, fine. So this is how the pre-processing algorithm will look like. Now let's see how this algorithm fits with this LPS table. Let's see how this algorithm fits with this LPS table. We'll do a dry run, okay? So I'm writing it in red marker here. So this is our pattern and these are the indices of it, 0, 1, 2, 3 and 4. Okay. So we have two variables, length and I. Length is initially 0 and this is your LPS table. So we have said that LPS of 0 will always be 0. Now the length is 0 and I is 1. Okay. 0 and 1, are they matching? Yes, of course they are matching. So we will enter this if loop. Length value has become 1. LPS of 1 has become 1 and I has incremented to 2. Now 1 and 2, are they matching? No, they are not matching, and also length is not 0. So what we are going to do is, we are going to simply update the length values. Now length would be what? LPS of length minus 1, that would be LPS of 0 and that would be 0. Now length is 0 and I is 2. Are these two matching? No, they are also not matching. So this condition becomes true. Now when the length is 0, so LPS of I becomes the length. So this value would be 0 and we would be incrementing the value of I. Okay. 0 and 3, are they matching? Yes. So we will increment the value of length and we will increment the value of I as well, and this would be 1. Now 1 and 4, are they matching? Yes. So we are going to increment both the values. Okay. So this value would become 2. And now we will exit from this while loop because this condition is not true now. The value of I is not less than M. Okay. Is this the same? Yes, of course. This is the same one that we saw yesterday. So yesterday we saw how theoretically we can create the LPS table, and today we have seen it with the help of the algorithm. Now let's see how the actual KMP algorithm works like, or how does it looks like. So it would be void KMP algorithm, and we are just going to pass two things here. One is the pattern and the other is the original string. I'll name it as text. And let's say the return type void, already mentioned. We would initialize a couple of variables as like m equals to pattern's length, pattern.length, n would be text.length. We would initialize two pointers I and j for text and pattern respectively, and both would be equals to 0. We will also create the LPS table with the help of the above method we have seen. So I am going to write it here like pre-process LPS table, and the input that it requires would the pattern and the length of the pattern. Okay, fine. Now what we are going to do is we are going to have a while loop while n minus I is greater than m minus j. Basically what does this mean is, while the number of characters in the text, in the original text in which we have to find the pattern, should always be greater than the number of characters left in the pattern. So let's say there are 2 characters left in the pattern, whereas only 1 character left in the text. So we are not going to compare it. We definitely know that this substring will not fall under that text. So this would be the condition of exiting here. We could also write that like while n is greater than I or m is greater than j, but this would be a little more optimized. Like every pattern matching, we will first match the characters of both the pattern and the text. So we will be saying if pattern of j equals the text of I, if these two things match, what we do? We simply increment the I and the j counters. Okay. Then we check after this if j equals to m. If all the characters of the pattern have been processed, then what we are going to do is we are going to print pattern has been found at the index I minus j. Pattern found at index, and what would be that index is I minus j. Okay, and since we want to find all the patterns that exist in the text, we are going to reinitialize or assign a different value to j, and that would be LPS of j minus 1. Now let's say even so, if j equals to not m, then what we are going to do is we are going to check if I is less than n. Yes, it is, and pattern of j is not equals to text of I. So basically one condition was that the two values have matched, the two characters have matched, and the other condition is the two characters did not match and I is also less than n. Okay, so this would be else if this condition. Then what we are going to do is we are going to check what is the value of j. If j equals to 0, then we are going to simply do a I plus plus, because we know that all the characters that have been processed in the text till now will never match with the pattern, because j is already 0 and we are saying that the two characters in the pattern and the text with the respective pointers I and j are not matching. So we are going to simply increment I. But let's say the two characters did not match and j was also not 0. Then what you're going to do is else you're going to initialize j as LPS of j minus 1. So this is how you will get all the patterns in the text that exist, all the substrings in the text that matches with the given pattern. Thank you for listening. Please do comment if you have any doubt.